Hi Shiva.
Hi sir.
So what is your demo today?
Today I'm going to do the EKS cluster with the simple by one simple web page by using the Terraform as an infrastructure as a code. So this is our demo today with the help of
Okay.
Terraform code. Okay, so let's go to the solution part. First of all, these are the tasks which I am going to perform. So first of all, I need to create one web provider Terraform file. So in Terra provider, we can give the provider details in that file, and next we need to create a VPC network. So inside VPC, we need to create all the things which we have required, whatever the configuration files. So in order to create VPC, so let's create the VPC network file, and we need to create one EKS cluster inside the VPC network. And we need to create the security groups for the cluster as well as the nodes, and we need to create one Kubernetes deployment file in order to deploy the simple web page to access from the browser. And in order to access this deployment file, we need to create one Kubernetes service with the load balancer. And next, we need to create the versions also. You need to mention all the versions, VPC as well as the EKS and the Kubernetes versions inside the versions.tf file, and you need to create even the output file, and you need to mention the details about the cluster name and ID of the cluster and the endpoint of the clusters. All the things you need to mention in the output.tf file. And at last, you need to execute the Terraform commands in order to create the infrastructure in the AWS console. And you can access the web page by using the Kubernetes service load balancer with the DNS name, and this is the last step. You can access the web page at the end.
Okay.
Okay.
You with DNS name. Okay.
Yes. Yes.
Right. You
So
please go ahead.
yeah. So the task one is first you need to create one provider TF file. So here I have taken the provider AWS provider, and I have mentioned the region with the US West 2 region. So you can mention with your requirement as well. And I have taken the availability zone here. For that, I have taken the data resource with the availability AWS availability zones, and I named it as available with name. And I have taken inside the locals, and I have just mentioned the name of the cluster name is the EKS cluster. So this is our first provider.tf file, and this is the task one. So in task 2, first we need to create the VPC and the network components. So first that I have taken the module VPC, and this is the source name Terraform AWS modules VPC AWS. So this I have taken from the uh, Terraform official website. So now I'm considering the name is the test VPC, and I have taken the IP address with the 10.0.0./16, and with the availability zones I have mentioned assigned with the data AWS availability zones. Right here I have mentioned right in the provider.tf AWS availability zones dot available dot names. So I have configured in the availability zones variable inside the VPC network, and I have taken the public subnets and private subnets. So I have taken the public subnets 3 subnets, and as well as private subnets as also 3 subnets, and I enable the NAT gateway. So because in order to connect the private subnets to come, the traffic will redirect to the outside. So we need to connect the NAT gateway. So for that I have taken the NAT gateway, and it is true. You can enable the NAT gateway with the true value, and I have taken the single NAT gateway for the demo purpose, and I enable the DNS name also in order to access the web page from the outside of the internet, right? So I just mention the enable DNS name host name equal to true value, and I have mentioned the tags for the VPC network. So for that I have taken from this Kubernetes from the Kubernetes official website for the cluster kubernetes.io cluster, and this is the local cluster name is equal to shared and also the public subnets and private subnets. I have taken the tags names also for the same shared from the shared value, and this is with the role ELB for the public subnet tags, and for the private subnet tags I have taken the internal ELB. So we have two types of ELB schemes. One is internal and the another one is internet. So this is for internal communication and this is for ELB, right? So this is our VPC network configuration file. So let's go to create EKS cluster. So for that I have taken the module from the Terraform official website and enabled it as EKS. So the source is the same as we discussed earlier. This is the source, Terraform AWS modules VPC, but here this is EKS for the EKS, Terraform modules EKS AWS, and the version I have taken the 18.0, which is the latest version. And the cluster name I mentioned it as the local.cluster name, and I have taken the cluster version with the 1.22, and I need to mention the connect to the subnet IDs. For that I have taken the module VPC module and the private subnets. Have connected with the private subnets, and let's connect with the VPC with this module dot VPC ID. So let's create the nodes also for the cluster. In order to create the node cluster, I need to mention the EKS managed node group default, and I have taken the one variable with carpenter, and it is the default root volume, as we can see in the AWS console. Root volume type is GP2, and I need to create the node groups. So for that I have taken the EKS managed node groups, and I have mentioned with one blue variable, and I have configured all the name and instance type, additional user data as well as the security group to connect with the port number, and I just mentioned the auto scaling group capacity with 2. So these are the configuration I have done with the name worker node group 1, and I have taken the instant type is T2 medium. So you can take as per your requirement all the configuration whatever you have configured now, and I have taken the user data with the simple echo node 1, and this is the security group to connect with the node group 1 with node group 1, AWS security group dot node 1. So for the another node 2 I have taken another variable with the green. So the similar configuration I have done here, same worker node 2 group 2 as well as the type instant is T2 medium, and the user data is echo node 2, and I have configured the security group also for the this second node group AWS security group node 2 ID, and have taken the desired capacity with one value. So it will create 1, and it will auto scaling group will create a 2 for the node. So this is our EKS cluster. So now I need to create one EKS cluster. So for that I have taken the data resource from the Terraform website. So I have named it with the cluster, and I have taken the name with the module.EKS cluster.id. So next further I need to create the authorization for the cluster. So for that I have taken another data resource with the AWS EKS cluster authorization with named it as cluster, and I named it with the simple configuration module EKS cluster ID. So at last I need to provide the Kubernetes details also in order to connect with the EKS cluster, and just I'll go through with the host as well as the cluster cluster CMS cluster authentication certificate, as well as I need to configure the token also for the EKS cluster in order to access the cluster authentication. So this I have taken from the Terraform website data.aws EKS cluster.endpoint, the host name is, and for the certificate I have taken the 64D code as the data AWS EKS cluster. So a cluster certificate with authority, as I mentioned the 0.data, and the token is AWS EKS cluster authentication cluster token. So this I have taken to configure inside the Kubernetes provider. So that's all about our EKS cluster. So Next, I need to create the security groups in order to access the ports from the nodes. So for that, I have taken the resource security group with I named it as node 1, and this is the prefix with node 1, and I need to mention inside the VPC. For that, I have taken the module vpc.vpcid. So next, I need to configure the inbound rule like ingress with ingress variable. We can access the 22 SSH port number from this node 1 with the protocol TCP, and I give the output to block is with 10.0.0./8. So you can take this configuration as per your requirement. This is for node 1 security group. So for the node 2 security group, I mentioned the same resource name with the node 2, and the prefix name is node 2, and I need to mention the VPC ID. So for the inbound rule, same configuration I have done here with the SSH port number 22 with the protocol TCP, and I have taken the IP range with 192.168.0.0/16, same configuration, and I need to create the security group for the node also for the EKS cluster control plane. So for that, I have taken the another resource with the AWS security group for the node, and I have configured with the node prefix, and I mentioned with the VPC in order to connect inside the VPC. So this is for inbound, same configuration, like you need to connect with the port number 22 through SSH with the TCP protocol. And just I mentioned all the three configuration, whatever I have done in the previous IP ranges, and along with the node IP range, I just mentioned everything here, configured here. Okay, so these are the security groups for the nodes as well as the control plane cluster. So next, I need to create one Kubernetes deployment file. So here all the things, whatever the website configuration, we need to mention here. So for that, I have taken one resource with the Kubernetes namespace. So first of all, I have created one namespace with the class cap, and I mentioned it under the metadata section. The name I have taken the class cap value with the name variable. So next, I need to create the deployment. So in order to create deployment, I have taken the another resource with the Kubernetes deployment, and I have named it as a class cap. So I need to mention the metadata same as, and I have taken the name with the class cap same value, and I need to mention the namespace with the Kubernetes namespace dot class cap dot metadata, and I need to mention the specifications in order to create the application with the replicas. I have taken that replicas as one value. So you can take suppose if you want 10 or 20 or anything, if you can want, you can take from the in this section under the specification section inside the replicas, and you need to mention the selector. So suppose if you have the the selector is the main component here. So suppose if you have the hundreds of containers, you want to deploy the web page in particular containers or pods, so you need to mention the selector. So the match labels, under the match labels, I have taken the name with the class app. I configured with the app, and you need to mention the template also. So because based on the template, it will create the replicas on the particular pods with similar configuration. So for that, I have taken the template with the under the metadata. I have labeled with the same name, app with the class cap. So these names should be the same name. So you need to mention the same name here. Otherwise, it couldn't configure and it couldn't deploy to the particular containers. Whatever we have configured, that should be the same name. And I need to mention the specification details for the container. These are the details which I need to require to create the pod inside the to create container inside the pod. So for that, I have taken the image from this latest class latest, and I have taken the name with the class container, and we can access the port number with the 5000. So these are the details I have needed to create the container inside the pod. So next, you need to create the Kubernetes service file in order to access the deployment, right? So now just we have created the Kubernetes deployment file. So now in order to access the Kubernetes deployment file, you need to create one Kubernetes service file. So for that I have taken the resource name with the Flask app, and I named it as a Flask app, and you have taken the metadata. Under the metadata section I have taken the name with the Flask app value, and I mentioned with the namespace as we configured earlier in the Kubernetes deployment file. And I have taken the specifications for this service also. So based on the selector it will configure inside to the deployment service. So for that I have taken the application with I have configured the previous file Kubernetes deployment under the Flask app, under the specifications and under the template, right? So here I have configured the template. Based on the template it will create, right? So under the template inside the metadata I've taken the labels with the application. This name application with the Flask app. So here I mentioned the type is load balancer. So because if something happens inside the pod or container crashes, if anything happens, then the cluster will take care of it. So we'll just mention here load balancer, then the end user can access the web page at any time. So I have mentioned with the port 80 inside, and can access the web page with the 5000 port number. This is the Kubernetes service file. So let's configure the whatever we have configured earlier, the cluster names. Let's configure inside the output file. So I've taken the output with cluster ID, and I mentioned with this is the EKS cluster ID name, and I have just configured the value with the module EKS cluster ID. And in the same similar way, cluster endpoint we need one output. So for that I have taken value also with the module EKS cluster endpoint. So this is for endpoint of the EKS master node, and I have taken the cluster security group. So earlier we have created the security group also for the cluster master, and this is the security group we need to attach to the cluster master node, and I have configured with the value cluster security group with the module.eks. So you need to mention the cluster name also in order to see the what is the cluster name. This is the Kubernetes cluster name under the local cluster name. So we have created inside the local, right, at the earlier. And finally we have created one load balancer with the host name, and we have configured it with the value that the Kubernetes service. So we have created the load balancer inside the Kubernetes. So that's why I have configured with inside Kubernetes the Flask app, and the load balancer with the ingress. This is the inbound with the host name to the configured with value. So this is our output file. So I have taken the versions also in order to work with this Terraform and Kubernetes. So this is our Terraform version with the 0.13, and the required provider I have mentioned the AWS. So because I have created the infrastructure in the AWS console, that's why I have taken the AWS, and the source is actually from the I have taken from this source this AWS. The version is 3.72. So this is the TLS source Azure from TLS, and the version is 3, and we need to, at last we need to take the Kubernetes version also from the source. I have taken the Kubernetes version 2.10. So these are the versions I need to require to configure inside this file. So after that we can execute these commands. Okay, so I have created the folder in my local. Okay, this is my this is my files which I did just discussed in the now. So let's execute. Before execution, let's go to our command prompt. Okay, just next to do. Okay, I'll take another version. I'll just mention another one. Let's go to command prompt. Click on this. So you need to change the directory of your current directory. Whatever you have created the files, that location you need to mention. Okay, let's execute cd. Wait, cd. This folder. Let's take copy this. You need to mention here. Enter. So now let's configure the AWS configure command. Enter. You need to mention the access key as well as the secret key. So that I have. I have my local. So let's give the access key ID. And in the similar way, secret key as well. Just enter. So I'll take the region US east to of your region. Enter. Enter. So let's execute our commands. The first one is the Terraform init. So it will initialize the deposit and it will create initialization. So for that, let's execute Terraform init. Enter. So whatever we have configured the modules and the specifications, it will downloading from the AWS module IKS. This is the version 18.30 we have mentioned in the EKS cluster. So these are the modules from the official image. It will initializing with this Terraform init. The provider plugins also initializing with these versions, latest versions. So it will take a few seconds. So just we have created our Terraform files with as a VPC as well as EKS and security groups and Kubernetes deployment file, and as well as Kubernetes service and the versions and the output. So we have now executing the Terraform commands to create the infrastructure and the AWS cloud. So still it is initializing the versions. So let me wait for that. Okay. So now the Terraform has been successfully initialized with all the required plugins. So let me execute the Terraform Terraform plan. So in order to create the resources, let me exclude the Terraform plan. Okay, enter. So this indicates that the whatever the resources and the files, it will be ready to create the resources with the AWS cloud with this Terraform plan command. So it will show all the resources and the required. Yes, so all the things, almost the 61 resources, it will added to the with the Terraform command. So let's apply the changes in the AWS console with the Terraform apply. So whenever you apply the Terraform command, so that whatever the resources it will added, so it will configure all the things and it will changes the resources and it will created on the AWS console. Okay, enter a value. Yes, enter. So all the resources will be creating now on the AWS cloud. So VPC, IAM role, Elastic IP, and the subnets also, security group, everything, whatever we have configured those files. So the resources are executing now. So it is creating all the resources with the help of Terraform apply command. So because almost the 60 resources are there, so it will take time. So let us wait until it is creating all the resources. So all the modules are creating now. Okay. So once it is created, we can verify in the AWS console on the same region, US East. So let me wait few minutes to create all the resources, right? It is creating still. Okay, let me wait another 2 minutes. So the cluster is also creating. Still, it is taking time. Okay. So normally the cluster is taking time, right? So let us wait a few minutes. So cluster, AWS EKS cluster. Almost it has 5 minutes. So still, let us wait. Okay, it is taking time still. We'll wait a few more minutes. So I think no, it is ready. I think okay, let us wait. Anything goes. Okay. What group is about creating? Submits public submits. Okay. Okay, let me go to AWS also. Copy your vision, right? So go to VPC. So let me verify. Okay. test VPC is created because we have given the name test VPC, right? Okay, let me show that. Yeah, test VPC name. Similarly, in the subnets also. Test VPC public subnet, test VPC public subnet, as well as the test VPC. The private subnets are also available. 3 public subnets. This is 1, this is 2, this is 3. And with the route tables, we have done with the test VPC. Yeah, public is there. Test VPC private is there. Then gateway. With test VPC, internet gateway is also attached to our VPC. Okay. Let's go to our NAT gateway. Okay, test VPC USST NAT gateway is also created. Let's go to security groups. The EKS cluster node, worker node 2, worker node 1. Okay, 3 are created. We go to EC2 as well. Okay, still instances. Okay, here there is no instances created still. Okay, let me open this also. Now deployment is creating. Now the instances nodes are creating. So nodes are creating, right? Now the service is creating. Okay. So okay, fine. Yeah, the resources are 61 added, 0 change and 0 destroy. So these are the in the output file. We have mentioned the ID as well as the endpoint and the cluster name, security group. Finally, the load balancer DNS name, right? So let's take this. Okay, let's verify in the console. Yeah, our worker node 1 and 2 now is running state. Let's go to load balancer. Sorry. Okay, this is October 16, right? Okay, now this is October 22nd. Okay, today. So this is our load balancer. Okay, let me take this. So what instances is in? Okay, one of two instances in service node 2. Okay, let me verify with this DNS name. So the load balancer will redirect to the second node, right? Because here only one instance is in service. So the load balancer will traffic will redirect to the worker node 2 instance, but still it is out of service. Somewhere we have misconfigured. The nodes are okay, running state only. Yeah, okay, fine. Let's take. If you want to give the username, let's give. Can give your name. I'll just give the 3 number. Let's start chat, and you can type something messages, and you can type your and you can send it to that person, right? So this is yeah, we can access the web page by using the load balancer DNS name, right? So this is today demo with EKS cluster with the help of automation Terraform as an infrastructure as a code.